Find the volume of the solid that results when the region enclosed by the curves is revolved around the x-axis. All right, so basically what we're doing is we're taking this little circular looking thing right here, and we're pretending that that's like a, I don't know, like a piece of paper, like a 3D printer thing, and we're spinning it around. So what's going to happen is this little orb right here is going to spin around and create a 3D orb looking thing. All right. This method is called DISKS. Now there's another method very, very, very similar called washers that we're not going to use here. Washers is if you kind of have like a space, like when you spin it, you create like a donut or a space in between. It's called washers because just like the tool washers, it has a hole in the middle. Not this. This is called DISKS because you're going to spin it around and not have any space in between it. Now, what we're going to do is we are going to take the integral of whatever equation this is. So we'll call it r. We're going to take the integral of r, square it. We're going to have a lower limit and an upper limit, and we're going to throw pi in front of it. Now, if you're looking at this and saying that's kind of like the volume of a cylinder, you're absolutely right, because what we're doing is we're kind of creating like a continuously changing cylinder, if that makes any sense at all. Okay, so this is the method that we're going to use. Now, we have our r, that's our r. And if you're like, what about y equals 0? Y equals 0 is just a fancy term for the x-axis. Don't worry about it. Don't worry about it at all. Now, what we don't have yet is we don't have our limits of integration. We don't have a and b. So this is what we're going to do. We have to find where our curve, where r crosses the x-axis. In other words, where is negative x squared plus 1 equal to 0? Now, we can look at this and say, well, I think it's kind of obvious what the answer is, but you can never be too sure, ever. So since I'm not too sure, and since these numbers could be not friendly in the future, I'm just going to do it this way anyway. So I'm going to add x squared to both sides, like that. I'm going to square root both sides. Don't forget your plus or negative. And that gives me x is equal to positive or negative 1. So my limits of integration are positive 1 and negative 1. All right, so now I know what I have. I think if I do all of this here, that leaves me with enough room. So let's see if I can pull this off. I have pi times my upper limit, which is going to be positive 1, my lower limit, which is going to be negative 1, my equation, which is going to be negative x squared plus 1, all of that squared dx. Before I can even begin, I need to square that guy. So this is not as simple as squaring both numbers. This is a perfect square trinomial. So this gives me x to the 4th, negative 2x squared, right? And positive 1. Now I integrate. Pi comes along for the ride. This gives me 1/5 x to the 5th. This gives me negative 2/3 x to the 3rd plus x. My limits are negative 1 and 1. All right, so I'm going to now use the fundamental theorem of calculus. I'm starting to get a little nervous that I don't have enough room, but we'll find out. I'll just write small. Fundamental theorem of calculus says rewrite this guy, but replace every x with the other limit. So I have pi. Let's do a little bit of mental math. 1/5, because the numbers aren't that bad. 1/5 times 1 to the 5th is 1, so 1/5 times 1, easy. Minus 2/3. 1 to the 3rd is 1, so minus 2/3 times 1 is minus 2/3, plus x, which is plus 1. Okay, got it. Minus. The second part of fundamental theorem of calculus is write that out again using the lower limit. So I have 1/5 times x to the 5th, which is negative 1/5. Same thing's going to happen here, but that's going to be positive 2/3 minus 1. If you're looking at that, you're like, oh, well, this is the exact same. After I distribute the negative, this is the same as that. That makes sense because these guys are symmetrical perfectly. So I'm not going to lie. I'm just going to quick use Siri and find out what 1/5 minus 2/3 plus 1 is.
It's approximately 0.5333.
So 0.533, I'll leave it like that. That's no problem. 0.5333 pi plus 0.533 pi is going to end up being 1.0666 pi. And that's the DISKS method. Fun, 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 fun.